Welcome to This Explainer. Think about your morning commute for just a second. You hop in the car, back out of the driveway, and just cruise down the street. It feels so simple, right? Just a flat, painted surface getting you from point A to point B. But what if I told you that the smooth surface beneath your tires is actually the final layer of a massive, highly engineered recipe? We're talking a recipe that involves extreme heat, staggering weight, and a very precise mixture of ingredients that are carefully layered from the ground up. So today, we're going to unpack the hidden complexities of modern infrastructure and see exactly how roads are built. Okay, let's dive right into this explainer's 5-part blueprint. We're going to start with planning the path. Then we'll check out the core ingredients. From there, we'll walk through the 6-step construction process, meet the heavy machinery that makes it all possible, and finally, look at how work sites mitigate some pretty serious hazards. Section 1. Planning the path, setting the foundation. Because, as you'll see, a reliable road starts long before any actual pavement is poured. The prep work required to get a project like this off the ground happens in 3 distinct phases. In Phase 1, the planning stage, civil engineers aren't just looking at the present. They're analyzing current traffic volume and projecting how much it's going to increase in the future, all while balancing costs and environmental rules. Then we move into Phase 2, the design phase. This is where surveyors use modern tools to measure out the road's exact dimensions. They also map out the water flow, which is absolutely crucial to prevent the road from literally washing away later on. Finally, we hit Phase 3, which is earthwork. This is where the land gets cleared of trees and obstacles, and engineers rigorously check the soil's strength. If the ground is weak, well, they have to completely replace that weak soil with gravel, sand, or materials like cement, just to guarantee the ground can carry the immense weight of the road and all the traffic above it. Section 2. The core ingredients, the building blocks of infrastructure. If the earthwork is our prep kitchen, it's time to look at the raw materials we're actually mixing together. Now, what's really fascinating about this is how these specific ingredients work together in totally perfect harmony. It's kind of like baking a very heavy, very durable cake. First, the soil provides the ultimate base support. Then, on top of that, we have our aggregates. The coarse aggregates, your crushed stones, provide the heavy-duty strength and stability. But stones leave empty spaces, right? That's exactly why fine aggregates, like sand, are used to completely fill those gaps and make the mix incredibly compact. Then you've got binders like cement, lime, or fly ash acting as the glue that reduces cracks and keeps the whole shebang locked in place. Finally, admixtures are added to give the roads special properties, like extra water resistance or the flexibility to handle heavy traffic without shattering. But there's one ingredient that really stands out as the ultimate waterproof glue, and that is bitumen. Bitumen is a black, highly sticky material, and because of its extreme holding strength and its ability to resist harsh weather, it's absolutely vital for constructing highways, city roads, and even massive airport runways. It acts as the ultimate binder, holding all those coarse and fine aggregates together, which gives us that smooth, flexible, and waterproof finish that we safely drive on every single day. Section 3. The construction process. The 6 steps of paving. We have our plan, we've got our ingredients. So let's get to the main event and look at the methodology of actually laying down the road. The paving process is incredibly systematic. It kicks off with base cleaning and repair, which means fixing old potholes and clearing out any debris. Next up comes the tack coat, followed immediately by preparing and placing the hot premix. Once that's down, we move right into the rolling and compaction phase to squeeze out any trapped air. And finally, teams conduct rigorous quality checks before giving the final surface inspection. Only then is anyone actually allowed to drive on it. Let's zoom in and contrast steps 2 and 3 for a second, because the relationship between the tack coat and the premix asphalt is super vital. The tack coat is basically a thin layer of liquid bitumen. Think of it as a sticky foundation. Engineers use about 6 to 7.5 kilograms of bitumen for every 10 square meters, just to ensure the surface is tacky enough. And this is entirely so the next layer, the premix asphalt, sticks perfectly. The premix is that thick, heavy layer of asphalt and aggregates that paving machines actually spread over the road. Without that tack coat underneath, that massive premix layer could easily shift or slide around. Now, to get that premix exactly right requires some pretty extreme conditions. Before it can even be laid down, the bitumen and stones must be heated in a hot mix plant to a scorching temperature range between 150 and 177 degrees Celsius. To put that into perspective, water boils at just 100 degrees. Maintaining this intense heat during mixing and keeping it between 121 and 163 degrees when spreading it out is absolutely critical. If it cools down too fast, you just don't get a strong road.
Once that incredibly hot premix is spread out, it's time for compaction. To remove any air gaps and ensure a perfectly smooth surface, crews bring in the pneumatic rollers. These machines have a staggering weight of 15 to 30 tons. I mean, that's like rolling several adult elephants over the road. And to do the job right, they operate at a painfully slow speed of under 5 kilometers per hour, pressing down with a tire pressure of about 7 kilograms per square centimeter. They even have to constantly spray water on the roller wheels, so the hot asphalt doesn't just stick directly to the machine.
Now, you can't just eyeball a finished road and say, yeah, looks good to me. The quality monitoring phase is incredibly rigorous. Inspectors test the quality of the bitumen, the heat of the aggregates, and they conduct Marshall tests. Crucially, they perform field density tests for every 100 square meters of road laid. Their main goal here? To guarantee that the actual road out in the real world reaches at least 95% of the density calculated back in the laboratory. If it passes, the sign-off happens and the road can finally open up to the public. Section 4. Meet the machines, the heavy hitters of the worksite. Let's be real. You simply cannot mix 170-degree asphalt and compact it with 30 tons of pressure by hand. It requires some amazing engineering just to build the engineering. An active work site basically relies on 7 heavy hitters. You've got the asphalt mixing plant combining the hot mix nearby, the truck crane lifting heavy pipes, and that massive road roller we talked about handling the compaction. You're also going to see wheel loaders, tracked crawler excavators, and forklift trucks constantly moving earth and supplies around. But you really want to pay special attention to the motor grader. This highly specialized 3-axle machine is essentially the artist of the work site. It's used to perfectly level the soil, shape the base of the highway, and carefully cut the precise slopes and ditches needed for water drainage. Section 5. Hazards and Solutions. Mitigating Worksite Dangers. As fascinating as all this massive coordination is, an active road construction site is incredibly hazardous, both physically for the workers and environmentally for the surrounding area. So the crucial point here is that engineers have to approach safety with the exact same rigorous structure that they apply to laying asphalt. Literally every single hazard has a systematic solution. Environmental dust polluting nearby areas, that's constantly mitigated with regular water sprays. Fast-moving civilian vehicles threatening the workers, crews immediately install speed bumps, barriers, and traffic signs. What about the hazardous chemical fumes coming off that boiling bitumen? Workers are mandated to use proper ventilation and heavy-duty gloves. And for the general impact of noise and blocked paths on local residents, planners actively map out alternate pedestrian paths to keep the community moving safely. Like I said, every single hazard has an engineered solution. Which brings us to our final thoughts. We started by thinking about a simple morning commute. But after walking through the meticulous planning, the precise chemical ingredients, the intense heat, the 30-ton machines, and those rigorous safety protocols, the next time you cruise down the highway, will you see just a flat surface or a 6-layer marvel of modern engineering? Hopefully, this explainer has given you a newfound appreciation for the incredible hidden infrastructure right beneath your tires. Thank you so much for learning with us, and keep staying curious.